Hello, welcome to our monthly look at all things networking. Mike Leith here, Product Manager, and as usual joined by Ed Stanier, Product Specialist. Morning, Ed.
Morning, Mike. Morning, everyone.
Great subject today, Ed, networking virtualized environments. Just to kick off, how many systems you come across these days that have got some element of virtualization on the networks?
I'd say around half nowadays. It's certainly becoming a lot more common to see virtualized networks, particularly on, obviously a lot of legacy systems now are still running on old hardware, old operating systems, but I'm seeing a lot of cases where even for a basic reporting system or something, a new small batch of servers or something will now be in a virtualized environment. So obviously we've got all the virtual network inside to start thinking about.
Okay, well, so this is the agenda we put together. Ed, thanks very much. We added a bit at the end, as usual, about troubleshooting virtual networks.
Yeah.
I guess by definition, the problems that people come across on virtual networks are going to be different to physical networks?
That's right, yeah. It's probably worth pointing out that the fundamentals of the networking itself, the actual underlying protocols and everything, remain the same whether we're talking physical or virtual. It's just the way that we configure them, the way that we kind of present them onto a network. So there's obviously a whole different kind of way of troubleshooting a virtual network than there would be with a physical network. Perhaps now we're not as much kind of, in a comms room looking at a patch panel and a bunch of cables connected to switches. It's perhaps a little bit less of that now, a little bit less hands-on, and a little bit more looking at the actual configuration on VMware or Hyper-V or whatever virtual platform you're using.
So everything we've been learning over previous webinars about networking, it still holds true, apart from, of course, the physical layer.
Yes, absolutely that, yeah. So the way in which a virtual switch works is exactly the same in which a physical switch works, basically, and much the same for virtual adapters, and obviously we'll go through all this in a minute and look at the similarities and the differences.
Okay, over to you then.
Excellent, okay. So the first point there, obviously we've just mentioned, a virtual network and virtual network in itself, it provides the same features of a physical network. So this is a really important thing to start off with, because we don't want to reinvent the wheel, we don't want to confuse ourselves when we're looking at virtual networking. We've got to remember that the actual fundamentals stay exactly the same. So like I say, a virtual switch and a physical switch, they operate in the same way, exactly the same way. Much like a physical switch will look at its MAC address table to determine which port it needs to send traffic down, a virtual switch will do exactly the same thing. Although obviously we're not talking about physical ports now, we're just talking about virtual ports. But the actual mechanisms behind it are exactly the same. They're identical as they would be in a physical network. So we're going to actually look at the reasons why we are virtualizing things, and a lot of people may already know the benefits of it, but essentially we're consolidating now resources, we're consolidating servers, applications into kind of a single piece of hardware, and that's the main goal behind this, consolidation of resources, making things more efficient. We no longer need 10 servers in a big cabinet. We can just have one kind of big server with some redundancy built in, and we can now have as many virtual servers within that as the hardware allows for. And it's just worth looking at that final point, because a lot of people may get a little bit kind of scared almost about creating virtual networks and introducing virtual machines. There's a lot of kind of rumors and hearsay going around that virtual machines are less secure, but by design virtual machines are completely isolated away from each other, much like two physical servers would be completely isolated away from each other unless you introduced a communications link between the two. The same rule applies for virtual machines, so in no way are they any less secure. There's many cases to look at virtualization actually being perhaps a little bit more secure. There's just slightly different security considerations, which we'll actually come on to later on.
Yeah, that was one of my questions for you today, actually, Ed. Are these type of machines inherently more secure? And I think you're saying, I'm not sure, are you saying yes or no?
Yeah, it's a tricky question, really. There's arguments for both cases. It's the way in which we approach the security with virtualization a little bit differently to perhaps how we might approach, a physical estate of servers. And absolutely, a virtualization can, a virtualized platform can be more secure than a bunch of physical servers, because essentially now if we've got one piece of hardware, we've only got to now secure one piece of hardware. But obviously the considerations for securing that are different, because if someone was to gain access to this single piece of hardware, they've got access to everything. And that's where the differences lie. But we'll come into that shortly, yeah.
Talk about that for moving on.
Okay. So some of the benefits, the key benefits really, at least when we talk about virtual networking here. So to begin with, we alleviate load on the physical network by keeping network traffic within the virtualized environment. And we'll have a look at some kind of visual examples of how this actually works. But essentially, imagine we've got two reasonably powerful servers that are under a lot of load and are sending a lot of traffic between each other. If we were to create those in a virtualized environment, that traffic remains on the virtual platform. It doesn't leave the physical NIC, it doesn't go onto the physical switch, and we're able to kind of alleviate a bit of a load now on the physical network. Imagine that we had these servers, these virtual servers as physical ones, and we plugged them into our network. We've automatically, increased the load there on the physical network itself. And for a lot of kind of legacy systems, old networks that perhaps aren't, up to scratch, still running on 10.100 where bandwidth is an issue, then virtualization can obviously alleviate that. The second point, so it's our ability to consolidate resources easily and save on physical hardware. So again, with virtualized networking, the way in which we create virtual ports, virtual switches, it's very dynamic in nature. We no longer have to consider, right, do I need a 24-port switch, a 48-port switch? How much is this hardware going to cost? When we start talking about virtual networking, we can add and remove virtual network cards, virtual adapters. We can add and remove virtual switches as we want. And we can do all this, dynamically without having to worry about buying additional hardware and that kind of thing. And then the final point is the easy administration and expandability. So again, if we want to start adding extra virtual servers, extra virtual networks, we can do all that from a click of a button. We don't have to start planning, new hardware and considering what hardware we'll need and that kind of thing. So those are really the main points, the main benefits for virtualization, virtual networking. Okay, so this little image here will hopefully just help to show the main components in a virtual network and where they kind of reside within both the physical and the virtual layer of things. So if we start right at the top, we've got VM 0 to VM 3 there. So we've got VM 0, 1, 2, and 3. They're essentially our virtual machines. So imagine that entire layer there at the top is sitting on one physical piece of hardware. Now underneath that we've got our virtual Ethernet adapters. So again, these are completely virtual. We've created these adapters within the VMs themselves. We've assigned IP addresses to them, much like we would with a physical adapter, and they essentially work in exactly the same way as a physical adapter would. For example, in Windows, let's say we've created a Windows virtual machine, we've added a virtual adapter, it will not appear any different than a physical Windows machine with a physical virtual adapter. We configure it in exactly the same way, IP address, subnet mask, gateway, all that kind of thing. So the configuration itself is exactly the same, and at this point we're kind of still in the virtual layer. If we look kind of in the middle there, we've got the vSphere 5 virtual switches. So we're talking VMware here. And these are our, again, we're still in the virtual layer at this point, these are our virtual switches. And these are what our virtual adapters will then connect to. So at this point, we are still completely virtual. We've got virtual machines, we've got our virtual adapters, and we've got our virtual switches underneath. So those top three components there, they essentially reside within the same physical piece of hardware. It's only when we move down a little bit here, we've got the physical Ethernet adapters. So if we want our virtual server estate and our virtual network here to communicate with the rest of our network, our physical network, then this is where we essentially integrate the two together. We need a physical adapter from our a physical server that houses all our virtual machines to then communicate with the rest of the physical network. And we'll have a look at some examples of how we would do that a little bit later on. But these are essentially the key components when you're looking at designing or even troubleshooting virtual networks. Your virtual machines, your virtual adapters, and your virtual switches. These are the three things that basically comprise a virtual network.
Okay. Ed, is there any reason you're not calling those NICs, the physical Ethernet adapters? Because that's what I would.
Right. Yeah.
I did flick through your slides, and I noticed you used the word NIC later on.
Yeah. They're completely interchangeable. Yeah. Right. Yeah. Some people will say adapter, some people will say NIC. They are basically the same thing. So you can call them NICs, you can call them adapters, as long as you remember that they're just the same thing, basically. Yeah. Okay, so we'll look at virtual interfaces or adapters or virtual NICs, we could even call them if we wanted to. So when we have created our virtual machine, if we want to start networking with it, we need to assign it a virtual adapter. And this is exactly the same as if we had a physical server and we plugged in a physical NIC to it. A new piece of hardware will be detected and we can configure it, plug a network cable in. In the virtual world, with a click of a button, we can assign a virtual adapter to our virtual machine and it will operate in exactly the same way as a physical adapter can. Now, we were talking earlier about the benefits and the way in which we can easily expand our networks and our virtual machines. We can add as many adapters as we want within reason. I believe there is a limit of perhaps 32 per virtual machine, but we can easily add extra adapters to our virtual machines if we want. We can do various things with those extra adapters, link them to different VLANs, link them to different physical segments of the network, but the important thing here is that we can easily add and remove them through the GUI, whether we're using VMware or Hyper-V. It's a couple clicks of a mouse button and you've essentially added a virtual adapter to your virtual machine. Now the point at the bottom is probably quite important to remember. Multiple virtual adapters can share a single physical adapter. So this is a big advantage to virtualization. Imagine we want to virtualize an old server. Let's say we have an old physical server that's only got one NIC in there. We could in theory have 3, 4, 5, however many virtual machines we want on there, all sharing that same physical connection to the rest of the physical network. So we don't have to have a one-to-one relationship of virtual NICs to physical NICs. We've got multiple options when it comes to actually configuring the physical integration. Okay, so the next key component then, virtual switches. And as I mentioned before, these operate in exactly the same way as a physical switch. So a physical switch is very simple at layer 2. If we're not talking about a layer 3 switch here, let's say we're just talking a standard layer 2 switch. Can we talk layer 3 switches? Are we just limited to layer 2 switches in the virtual world? Well, we aren't actually limited as such to just layer 2 switches. Kind of off the shelf, if you were to just buy a standard kind of VMware license, you would be limited to just a layer 2 virtual switch. But we can configure virtual appliances that will essentially act as a layer 3 switch or as a router. So we still do have options to do routing and layer 3 functionality in the virtual world. It's perhaps just not supported directly from, a basic VMware license, for example. We might need an extra virtual appliance. There may be free ones out there. There's obviously a lot of vendors who will charge for that as well. But there is nothing stopping us from doing that. It's just a little bit of extra configuration. We don't really touch upon it too much in this webinar. Just give me a feel though, is that really unusual, or are you coming across it? I do come across it actually, particularly in a large virtualized project, especially where you've got, let's say, a multi-site virtual project. So we've got virtual estates around different sites and we need some kind of routing between them. And sometimes that does happen at the virtual layer. Generally speaking, I only see it in much larger organizations, much larger networks. It's not as common to see in smaller scale projects, to be honest, just because it's quite unnecessary. When you're only talking a small handful of virtual machines, there's not as much of a desire to route between them. So I do see it, perhaps not as common, and it's probably something that people don't have to worry about too much right now. It's certainly an extra layer of complexity if we start talking virtual layer 3 switches. Maybe one for the future. Then. Exactly, yes, yes. So yeah, a layer 2 virtual switch then, very simple, just as a physical switch, it will consult its MAC address table and make a decision on how it forwards traffic. Exactly the same in the virtual world, except we're talking virtual ports here instead of physical ports, but it still works as a basic lookup table. So no difference between a virtual switch and a physical switch in how it operates. Now, the only thing I would say, when we create a virtual switch, when we first create it, we are essentially creating a switch with no ports on. So in the physical world, we've got to decide, do we want an 8-port, 16-port, 24-port, 48-port, or whatever. In the virtual world, when we create a virtual switch, to start with, there are no ports allocated to it because we've got nothing connected to it. If we were to then create a virtual machine and create a virtual adapter and assign it to that virtual switch, then we've just created a new port on that virtual switch. It now has 1 port. And that will keep changing. Every time we allocate a virtual network card to a virtual machine and we allocate the virtual switch to it, we create an extra port for it. So the ports are dynamic in nature with virtual switches. We're no longer limited to 48 ports or whatever, and actually the maximum there is 1016, which is obviously a huge amount of virtual ports to use. It's unlikely you'll ever get anywhere near that limit. But obviously there are some advantages to that, to having a switch as dynamic in nature. We can add and remove as we want, and we don't have to worry about running out of port space really anymore. The consideration now in the virtual world is if you have enough resources to manage that number of switches, as opposed to do we have enough physical ports to actually plug into this thing. So that's the only consideration. But if your hardware is spec'd correctly, then it's not something you have to worry about unless you are looking at building very large-scale virtualized environments with 100+ virtual machines, or with multiple virtual adapters in. Much like in the physical world with managed layer 2 switches, in the virtual world we can also do VLAN tagging. So we are able to have multiple VLANs to exist within a virtual architecture. Again, that's a big advantage. We can now cross over from the physical world to the virtual world with the exact same integration as we've got in the physical world. So if we've got multiple VLANs in our physical world, we can present them into our virtual layer as well with VLAN tagging at the virtual switch layer.
You typically just match your physical VLANs to your virtual VLANs.
Exactly, yeah. As long as your tags match up, that's all you've got to worry about really. So there's nothing really we can't do in the virtual world with virtual switches that we can do in the physical world, to an extent anyway. Okay, so we're going to look at an example here of how a virtual switch would operate. Let's start on the left-hand side. So we've got 2 VMs, VM1 and VM2. And this is essentially just a production LAN or a production VLAN. Now, those two, we can see the icon of the NIC there connected to the virtual machine. So they are just virtual adapters, virtual NICs, and they connect to that virtual switch there, that blue virtual switch right in the middle. Now, on that virtual switch, we have 2 physical ports represented as little black boxes. And they're shown as connected to those physical NICs there, which then in turn connects to a physical switch. Now, the important takeaway point from this is VM1 and VM2, they're on the same LAN, we're in the same subnet. If they want to talk to each other, they will send their traffic to the virtual port, which in turn connects to the virtual switch. And the virtual switch will do its lookup in the MAC address table. It will see that VM2 is another connected port. And basically, the traffic between VM1 and VM2 resides within the virtual switch. So it never leaves the virtual layer. So traffic between VM1 and VM2, it stays within that V switch. It doesn't go out to the network and come back in. It doesn't go out to the physical network and come back in. It stays there. So our first point, our first advantage to virtual networking we talked about was the ability to alleviate stress on the physical network. That's the example there of how we would do that. If your virtual machines are within the same V switch and they're within the same VLAN and the same subnet, then that traffic will never leave a V switch. It will never be presented onto your physical network. So that's a big advantage there, particularly if we're talking about virtual servers that are sending a lot of traffic, and they're quite bandwidth hungry, should we say. So that's the most basic example of a virtual switch and how it would be set up. So now we're going to add a little bit of complexity to it. Again, we've got VM1 and VM2. We have them in the same network still. So they're both in the same subnet, the production subnet. However, we've got them connected to two different virtual switches. We've got vSwitch1 at the top and vSwitch2 at the bottom. Now, in turn, both of those vSwitches are connected to two physical ports each, which then in turn connect to a physical switch. Now, if we want to communicate between VM1 and VM2 here, then as you can see, the traffic has to leave a vSwitch, be presented onto the physical switch, and sent back through the other vSwitch. In a lot of scenarios, in kind of more basic virtualized environments, we probably wouldn't have this setup. We would most likely have a single vSwitch. But this is just a representation to show that if you create two different vSwitches, there is no link between those two. They cannot talk to each other. Much in the same way as if you had two physical switches, if you've not got a link between them, they can't see each other. And that's where we are then sending traffic out to the physical switch, which is then in turn coming back into the other virtual switch. So that's just an example if we had multiple switches, multiple virtual switches connected to like a physical single switch. Okay, so we're going to have a little look at virtual security now. There are some similarities and there are some slight differences in the security considerations in the virtual world. But essentially, the same principles themselves will apply to securing virtual machines as they do securing physical devices. So when we're talking about network security, we have to understand that a virtual machine and a physical machine will operate in exactly the same way. We can still have potential exploits in applications, in the operating system itself. If we're not locking ports down at a layer 3 level or a firewall level, then we've still got the same potential vulnerabilities that we would have in the physical world. With that in mind, the virtual machines themselves are completely isolated away from each other, even though they reside on the same physical machine. So if we're talking about two different virtual machines on one physical piece of hardware, you have to treat them as completely isolated. There is no known vulnerability in VMware, at least to my knowledge, of any potential exploit for those two to be able to see each other. For intents and purposes, if you were to, let's say, remote desktop onto a virtual machine, you would have no idea it was virtual or physical, unless obviously you had prior knowledge. So a virtual machine cannot talk to another virtual machine that happens to be on the same physical piece of hardware unless you've created a way for it to talk to it. So they have to put your kind of trust almost into a virtual platform that there is that complete and utter isolation, and there is no known way of exploiting that. And obviously that brings us on to our final point there. If you have virtual machines on different VLANs or different subnets, you'll still need that layer 3 device to communicate with each other. So there are no shortcuts in the virtual world here. We can't just magically make two different VMs on different VLANs just talk to each other just because they're on the same physical bit of hardware. We still need to adhere to the rules of networking in the OSI 7-layer model. We still need that layer 3 device to route between them. And whether that's a virtual one, like a layer 3 switch that you mentioned, Mike, or whether we need to go out to the physical network and route it on a router, a layer 3 switch, or a firewall, we still have to adhere to those rules. So we're going to have a little look at an example here of how we could potentially create some security, some perhaps access control lists between two different VMs. So what we've got here, it's perhaps a little hard to see at the top, we've got VM1, we've got that shown as data gatherer, and that's on a PLC LAN, and that's in turn connected into vSwitch1. At the bottom we've got VM2, and that's an application server in the SCADA LAN. So we're looking here, two totally different networks, two different subnets. We've got 10.10.1.1 and 10.10.2.1. Let's assume a standard subnet mask of 3255s, and those are basically completely different networks. So we've created a virtual switch for each one. We have linked our physical adapters to those virtual switches, and in turn those physical adapters then connect into let's say a managed layer 2 switch there on the kind of middle right hand side. In turn, that switch then connects into this firewall, which acts as the default gateway for both of these networks, both the PLC LAN and the SCADA LAN. So, like I said before, there's no magic in VMware that will allow these two virtual machines to talk to each other unless they go through the firewall, which is the default gateway for both of them. Now, we've covered a similar example like this in a previous webinar where we use a firewall to act as a gateway, so like a routed mode firewall. And at that point, we can introduce access control lists, we can start filtering traffic out, and we've got complete security now between our data gatherer VM and our application server. So we've got security between our PLC LAN there and our SCADA LAN. And like I say, all we're doing there is we're just presenting our virtual machines onto the physical network, and we're allowing a physical device, in this case the firewall, to do the routing and also to implement some security, some access control lists, that kind of thing. Now, probably one of the biggest things to consider with security in the virtual environment is the management layer. Now, in the case of VMware, for example, once you have access to the management layer, once you're able to log into the vSphere console, you essentially have the keys to absolutely everything within that physical piece of hardware. So you can access all your virtual machines, the data stores, the configuration of all the vSwitches. So really the security of the management layer is really paramount, because once someone compromises that, then they have, you know, complete opportunity to do absolutely anything they want within your virtual environment. So really it's very, very crucial that your security of your management layer is kind of top notch. So basically the key thing to take away is that we want the management network or the management layer on VMware or Hyper-V or whatever it is to be on a completely isolated and well-secured network of its own. So we don't want to start having our management IP address on the same LAN as our engineering LAN or our PLC LAN. That's just very, very bad practice. We want this completely isolated. We don't want anyone to even be able to get to the login screen of our management layer unless they're authorized to do so. So we don't want to put this on any other LAN apart from its own segregated management LAN, where we have complete control over who can and can't access it. So we'll have a little look at some examples of that. Okay, so this is similar to our example. We had our security example of our two VMs, our data gatherer and our application server. Now, if you look at the top there, we've got that little orange box, and that is essentially our management interface. Now, when we create our management interface, particularly in VMware, we have the ability to create a VLAN tag for that management interface. And that essentially says that, right, that management interface will only talk on this VLAN, in this case, VLAN 600. So what we've essentially done here is we are still sharing the same vSwitch, but we have a different port, we have a different port group. And basically, we are saying that only VLAN 600 traffic can talk to the management interface. Now, everything is then connected into our layer 2 managed switch there in the middle. And on that, we would then control which ports are on VLAN 600, i.e. which ports can actually talk to the management interface. So in this case, let's say, right, we've locked down that entire switch bar one port, which has a management workstation connected into it, and that management workstation will be in a secure office. You can't just have anyone come along and start tapping away on it. And that's the only way in to the management layer of VMware in this instance here. So we've got complete isolation over it. No one in the PLC LAN, no one in the SCADA LAN can talk to that interface, that 10.10.3.1 interface. Only that management workstation can. So this is a reasonably basic, but also a very secure way of locking down your management layer at VMware. And this is really important. I can't stress this enough. We do not want that management interface to be sat on the same LAN as the PLC or the SCADA LAN. Very, very bad practice. Now, this one is a slightly different example in that what we've done here is we have essentially created an entirely new vSwitch, a new virtual switch for management alone. And basically what we've got there is we've got one network interface card linked to that vSwitch, which then in turn connects to a management workstation. So what we're doing here is we're completely isolating the kind of physical layer as well. We're no longer going through the layer 2 switch there and obviously doing the VLAN inspection at that layer. What we're doing here is we are basically just having a physical link between the management layer to a single workstation. Now, this scenario is obviously super secure, but it's not as, it's perhaps not as practical. We're limited now. We've just got this one workstation that can talk to the management layer.
Would you say it's less flexible?
Exactly, less flexible, yeah. Let's say we want, in our previous example, if we wanted someone else to be able to access the management layer, we'd open up a port on a switch, assign it VLAN 600, off we go. In this instance, well, we've got other considerations. We could potentially connect a switch in between the management workstation and the physical NIC. That's one way of doing it. But obviously this is, as it stands there, a little bit less flexible. But we do have complete kind of control and complete physical segregation there. There's no physical link anymore between the management LAN and the rest of the physical network. Okay, now in this scenario, we are going back to the first scenario, and it's basically a little bit of a mixture. We've still got our own vSwitch there. We've got our own individual port, and we are tagging the management traffic again here with VLAN 600. So it's similar to the first scenario, but the difference here is we've now got our own vSwitch. We've set up a management vSwitch. We've got a physical port allocated to it. We're tagging at that layer, and we've regained a bit of our flexibility now. So if we wanted to start opening up our management layer to extra devices or extra ports on that switch, we can do by just simply assigning VLAN 600 to whichever ports we want to open up. So this kind of gives you a bit more flexibility in which devices you're allowed to talk to your management layer, but we've still got that segregation. And again, unless a port connected to that switch is VLAN 600, it cannot talk to the management layer. So although the representation on the diagram may not look as secure, we have to understand that with VLANs, they are essentially this completely isolated networks. They're completely separate from each other. They have no knowledge of each other, and unless you've got access to that managed switch, you will never be able to see those other VLANs. Okay, so most important point really in terms of connecting our virtual estate to the rest of our physical network, because obviously at some point, if we've got our virtual machines, we want it to talk to our physical estate, our physical network, and our physical servers. We need some link between the two. Now, it's actually reasonably straightforward to set this up. And essentially, all we need to do is allocate some physical ports on our servers to the virtual switches. So what happens there is a physical port becomes a member of a virtual switch, and in turn, that physical port then connects to our virtual switch. And that is how we essentially link between our virtual and physical network. Now, best practice is to allocate at least 2 ports to a virtual switch for redundancy purposes. Some people may go overboard and configure, you know, for 8 ports per virtual switch and have these really complex and, you know, how do we say? Yeah, I suppose complex is probably an understatement, where we're having, you know, 8 physical ports all for one single vSwitch. It's a huge amount of extra redundancy, which
over-engineered.
Over-engineered is probably, yeah, a good word to use, Mike. But really, best practice says that we should have at least 2 ports. If a port fails, then we've got an additional port to take over. We know we don't lose any connectivity. And in the world of perhaps a Stratus server, we will have 2 physical different segments on the hardware itself, which are completely isolated away from each other, and that's generally how we would approach virtual redundancy with like a Stratus server, for example. So if an entire board failed on our physical server, we've got a redundant port on the other board. So we've got kind of maximum redundancy there. Unless the entire server blows up, we've got a lot of redundancy. So really, we don't need to kind of over-engineer it too much. With that being said, we can, if we want, allocate up to 32 physical ports to a virtual switch. And this is just something to consider when if you are planning, you know, a project with virtual hardware and virtual networks. We need to look at, okay, how many different networks are going to reside on this virtual platform? How many physical ports am I going to need to ensure we've got redundancy for them all? And generally speaking, it's quite easy to upgrade the physical ports. But let's say we've got 3 or 4 virtual switches, then we're going to want at least 8 ports. That's 2 then, 2 ports, 2 physical ports per virtual switch. So we've got redundancy for all of them then. So when we're actually connecting the virtual world to the physical world, we will allocate our physical ports into port groups. And it's the port groups then in turn which will be linked to the virtual switches. So we can easily add or remove ports if we need to, and that's not a problem. And we then have the ability in our port groups to configure a number of different redundancy features. We can have load balancing features where we are essentially using both ports actively, or we can just have failover features where all traffic's just sent down one port and the other one will take over in case of an issue with the primary port. And some other cool features you can do with port groups, things like traffic shaping, bandwidth limiting, quality of service, that kind of thing. So really there's a lot of flexibility still in the virtual world. A lot of managed features you'd see in the physical world are there in the virtual world as well. So traffic shaping, quality of service, that kind of thing.
On the troubleshooting side, Ed,
yes.
Do you feel like you come across more problems on virtual networks than physical, or is it?
Well, I would say about the same. It's normally quite silly mistakes that will trip people up in the virtual world. And these I've kind of just shown some examples of the most common ones that I come across. And probably the first one here, if you've not got comms between a couple of virtual machines and you're certain your IP address allocations are all fine, everything else checks out okay. First thing to check is your vSwitch assignments. When you create a virtual adapter, it will ask you which vSwitch you want that to become a part of. Now look at this instance here, we've got VM1 and VM2 connected to two different virtual switches. They can't talk to each other. That's by design, they're not meant to be able to. So sometimes it's something as silly as the wrong vSwitch has been selected. And if the wrong vSwitch has been selected, we're going to have this scenario here, they just cannot talk to each other. So really that's the first troubleshooting step when you're troubleshooting virtual networking, check your vSwitch assignments. If you've got the same vSwitch assignment, then really those two VMs should be able to talk to each other because they're not leaving the virtual layer. We haven't got to even start looking at ports in the back of a server or anything like that when we're talking about two VMs on the same physical machine on the same vSwitch. This again is a common one, and this one's harder to spot. So this is about your physical connection from your virtual layer to your physical layer. And this scenario here where we've got our data gatherer at the top, we've got our application server at the bottom, we've got two different LANs there, and obviously we've got our firewall there that's doing the routing and the security access control lists between the two VMs. Now in that instance, the physical NICs we've allocated to vSwitch 1 are disconnected. They're not plugged into that switch. And the reason that can be hard to spot to begin with is because VM1 will still show as it's got its network card connected. So it will not show on network connections, but it's actually disconnected because your connection to the vSwitch is still there. It's a physical connection out to the rest of the world which is disconnected, but you won't be able to tell that from the virtual machine layer. So really this is something you'd have to look in, VMware or Hyper-V or whatever platform you're using. But you should be able to see the physical NICs you've allocated to that virtual switch. You should be able to see the status of them. Are they connected or not? And often people can get, when they try to do these slightly complex redundancy configurations where they've got multiple ports connected with varying different numbers, port 1, port 5, port 8, and people end up plugging the wrong ports in the back. Because also, if you've got multiple cards in the back of your physical server, you need to be able to identify which is which. Port 1 in VMware, which port is that talking to on the physical server. As long as you've got a good understanding of that, and a diagram can normally help, then you shouldn't run into this problem. But obviously, in this scenario here, VM1 cannot talk to VM2 because there's no physical link out to the rest of the network, so we can't route the traffic.
And I think you said in the past, being methodical and logical.
Yes.
Good documentation is
it's paramount. Yeah.
Element of
absolutely
networking.
Exactly. Yeah, because there's more going on now. There's these physical to virtual port mappings, so you need to have an understanding of that and have the knowledge of that. Otherwise, you can spend a lot of time, troubleshooting things that aren't even there.
You've got one more, Ed, have you?
Yes, I believe we have. Okay, so this is a common one, again, I've seen before. When you start introducing VLANs into virtual network as well, you have to make sure that your tags are set up correctly. So in this instance, what we've got is we're doing VLAN tagging at the virtual switch layer. So at the bottom, we've got our SCADA LAN being tagged VLAN 400. Middle one, we've got our PLC LAN being tagged as VLAN 500, and at the top we've got a management interface which should be tagged as VLAN 600, but it's not. It's being tagged as VLAN 500. And what's happening there is obviously our management workstation, which is connected into that switch with the orange line. That's VLAN 600, but the management interface is 500, so they can't talk to each other. You won't have any comms whatsoever between those two. So again, when you're introducing VLANs into your virtual world as well, always ensure you check your tags and make sure they match up both ends. Make sure your physical link is connected into a correct VLAN port on your physical switch as well. So again, it's just about being methodical and kind of some diagrams and some documentation on what you've got is very helpful in this instance. So you know for sure that port 1 goes to this switch and should be this VLAN, and you can check both sides there.
Okay, thanks, Ed.
Okay.
Well, that brings us to an end of the formal part of the presentation. We've had one question come in, Ed, so I'll just read it out for the benefit of everybody. And it's actually a question I was thinking about when you were talking about using one physical NIC. So the question is, when using one NIC to host multiple virtual adapters, are there any problems with bandwidth? Does quality of service become important, and can quality of service be implemented in VMs?
Yes, that's a good question. If you did only have, let's say, one physical NIC, you know, you're limited to that and you want multiple virtual adapters in there. If we're talking gigabit here, then generally speaking, unless you've got some really bandwidth-hungry VMs or applications, gigabit is really quite ample, even for 10 VMs or so. People normally underestimate just how much bandwidth a gigabit link is, and it is a hell of a lot. So I think unless you're talking about kind of mission-critical applications that require, you know, instant replies and cannot operate with any kind of congestion, or if we're talking about virtual machines that are doing a lot of bandwidth-intensive applications, then generally speaking, bandwidth isn't too much of an issue. With that being said, we can introduce quality of service. So in this instance, we perhaps have different virtual switches or different port groups, and we'd allocate certain quality of service rules to the ones that we wanted to give the most precedence to. But again, I mean, in this instance, let's say we've got 4 or 5 virtual machines, and a lot of the communications they're doing is within each other, so between each other, then again, bandwidth isn't a requirement because the traffic's never even leaving the network interface card. It's staying within the virtual platform. So I guess short answer, yeah, quality of service can be implemented, but people normally worry too much about bandwidth. I think if you've got a gigabit, then you shouldn't worry too much about it unless you've got some particular applications or some particularly really bandwidth hungry VMs. Then it's not anything you want to worry too much about.
I know in the physical world, when we've had bandwidth problems, it more often than not comes down to another problem in the network.
Exactly.
Rather than
as opposed to actual bandwidth, yeah. I mean, a good test in that instance would be to set up some kind of, you know, statistics on the physical port to look at the input and output, because chances are, if you think you have a bandwidth problem, you actually look at the statistics of the port, it's not normally as bad as you think. So that's your first point of call, really. Check how much bandwidth is the port actually using. But generally speaking, like I say, in the automation world, gigabit is a lot of bandwidth, because SCADA applications, they don't use up a lot of traffic, really.
Thanks, Ed, and thanks for the question. So just looking ahead to next week, an event we've got coming up. Ed, you'll be there at both events, not presenting. You've got a day off, so you'll be there to answer any questions, I'm sure.
Absolutely, yeah.
So I think at the moment we've got something like 150 people over the 2 events, so that's really good, but we'd like to see more. Keynote presentation from Jay Abdallah from Schneider Electric. He's the Global Security Director. We've got Clarity there as well, looking at IDS systems, something we've talked about before, Ed, intrusion detection systems on networks. That's something we're seeing more and more as a requirement, and certainly a topical subject. I'll be giving a short presentation on what we're seeing in the cybersecurity landscape, so it'd be great to see you there next week. Was that another question that's come in while we've been chatting? So I'll just read out the question. So monitoring port, if you need to analyze traffic between machines in a virtual switch, is it possible?
It's a very good question. Normally, obviously on a physical managed switch, you've got things like span and port mirroring that allow you to easily monitor a trunk port or something like that. Now, it's a good question because in the virtual world, if I'm honest, I'm not 100% sure if VMware virtual switches will support something like span or port mirroring. They may well do, but I'm not too sure because I've not done it myself. If we were talking about just two virtual machines in a virtual switch, then there's other ways in which we can monitor how much bandwidth is being used between them. With things like Wireshark and specific filters in Wireshark, we can use that to analyze how much bandwidth is being used. If we're talking about lots of different VMs within a single virtual switch and you want to monitor the total bandwidth of the whole vSwitch, I believe there are some command line things we can do with VMware that will give us those statistics. But off the top of my head, I couldn't tell you exactly what they are. Having said that, VMware and even Hyper-V, but VMware especially, is very flexible in terms of monitoring and the back-end command line stuff we can do. So I have no doubt that there will be a way for us to look at those statistics if we did want to, analyze traffic between lots of different VMs in a vSwitch. But as I say, if it's just between, two VMs, same vSwitch, we can do that at the VM level. We could do that with Wireshark, for example, and some filters set up in there.
Thanks, Ed. So, just conscious of time, but just industrial network training. Course for December, I think it's full now, that course, but there's places on the February one. And I know we get a lot of systems integrators joining us on these webinars. Next year we will be looking at doing a more advanced networking course geared more towards the needs of systems integrators. So if there's anything there that's of interest to you in terms of SI training, then please get in touch. We have got one more question, and I'm conscious that some of you might need to leave us, but we'll answer it now. It's about network speed, unlimited. Copying files between two machines will only be limited by disk I/O then?
Yeah, that is absolutely correct. If we've got two machines, two VMs, same vSwitch, as I say, that traffic will not leave the virtual layer. So yeah, your limitation there will be disk I/O and memory. So if you were looking at, you needed some VMs that will be doing a lot of intensive stuff between each other at the virtual layer, then yeah, you want to be considering the speed in which your disks can read and write. So, quick disks and that kind of thing. And this is kind of coming almost onto, storage array territory, where we look at things like jumbo frames and that kind of thing, and super quick 15K disks and things like that. But yeah, the short answer is yes, your limitation there will be disk I/O and memory.
Great question.
It's a good question, yeah.
Well, we talk about network and we talk about network speeds a lot.
Exactly.
We haven't even touched on it today, have we?
That's right, yeah, that's absolutely right.
So the speed is really down to the...
Exactly. Your virtual network card in Windows will probably report that it's running at a gigabit, but theoretically speaking, you could, depending on the speed of your disks and things like that, it may be more or less. So really it's kind of a loose term speed is within the virtual world, particularly when we're talking about staying in the virtual layer, staying on the vSwitch. We're not, we don't have a physical gigabit port anymore. Our limitation basically is disk I/O.
It's probably it is my ignorance. When you're setting up your virtual devices, do you actually specify a speed, or is there not even a...
If you wanted to, you probably could go into the adapter properties in Windows, for example, and set a negotiation speed, but I don't imagine it would be used. Well, perhaps the operating system would, but they should auto-negotiate, and like I say, most likely will report it as a gigabit, but I wouldn't pay too much attention to that because, like the question suggests, it's not the network speed anymore. We're not talking about the physical NIC here. We're talking about the I/O on the disk, how quickly it can read and write.
Okay. There are no more questions, Ed. So it just remains for me to say thank you, Ed, for a great presentation.
No problem, Mike. Thank you.
Covered some good stuff today. Thanks for your thanks coming through. And please look out for upcoming subjects, and we'll speak soon. Bye-bye.
Thanks, everyone. Bye-bye.